In this tutorial, I'm going to talk to you about limits with infinity, and that means that my limit is approaching infinity or negative infinity. So there's a couple rules that we know right away. So the first part here says for all n greater than 0. So we're just talking about numbers that are bigger than 0, and that can include decimals as well. So if you take a look at the first limit here, it says the limit as x approaches infinity of x to the nth power. So as long as n is positive, think of this number, think of any number plugging in here for x and raising it to a super big number. That will always approach infinity, no matter what. Now, let's look at the next case that's over here. It says the limit as x approaches infinity of 1 over x to the nth power. So as this part of the fraction gets bigger and bigger and bigger, what happens to this? Where does it start going? If you think about it, it's going to get closer and closer to 0, because that fraction is going to get smaller and smaller. It's going to be 1/2, and then 1/4, and then 1/8, or 1/16, and so on and so forth until it's so small that it almost touches 0. So then what about when x is approaching negative infinity? Unfortunately, the rules don't stay consistent. They can change just a little bit. So if I'm approaching negative infinity, remember that means that my numbers are getting smaller and smaller and smaller. So this exponent, even though it's positive, this number here is negative, and it just doesn't have the same behavior as it going towards a positive number. So there's a couple different rules here. So I can have one of two outcomes. Either this limit approaches infinity or it approaches negative infinity. In order for it to approach a positive infinity, a positive number, that exponent, that n, has to be even, because that makes any number, no matter what x is, it makes it positive. So the rule that we're going to put here is that n is even. So just by looking at this, it seems that in order for it to approach negative infinity, then n would have to be odd. And that makes sense, because if x is a negative number, having an odd exponent would keep that number negative, and then it would just get bigger and bigger and bigger. Another case is if x is approaching negative infinity of x to the negative nth power. So we can rewrite this very easily so that we don't have a negative exponent as 1 over x to the nth. And what we should be looking at here is if x gets more and more and more and more and more negative, then what happens to my limit? Where does it start going? We'll start thinking of very, very big negative numbers being raised to an exponent. Regardless of what happens, this number here, take for example, let's say x is, 2. And it's approaching negative infinity, so we'll make it negative 2. And it's over or under 1, and it's being raised to an nth power. So right away, our exponent now is going to be positive. So it doesn't matter what this guy down here is going to be. I am still going to be dividing by a number that gets more and more larger. So this then would be 1 over some very large number, which makes a very, very small decimal. So this limit is always going to be approaching 0. Now, some of these are not going to be super easy to see just by looking at what you're given. Don't forget that you are welcome to use your graphing calculator to check a lot of this and to see exactly what's happening. Now, there's a few rules for finding limits for rational functions. And if you remember, rational functions are fractions. And there are four main things that you need to look out for that make finding limits as you're approaching infinity very, very easy. And I'm going to show you them one by one. So let's take a look at an example. And this says that the limit as x approaches infinity of this rational function, 3x to the fourth power minus 7x plus 9, all divided by 7x to the fourth minus 4. Now, this may look kind of complicated, but there's a very short way of doing this. As long as the numerator and the denominator are ordered by degree, that means from highest exponent to lowest exponent, then all you have to pay attention to are the first two terms. So I could rewrite this very simply like this. And the reason is because when I'm raising some number, x, to a fourth power, the rest of that 7x plus 9 hardly has any effect on the gravity of this in any way. So if I know what's happening with this part of that fraction, of that rational number, that's going to tell me everything I need to know. So when, this is your rule, this is your first rule, when your exponents are the exact same, okay, so in other words, when n is equal to m, we call the top numerator n and the bottom exponent m. Okay, we're going to use some notation to keep everything nice and clean so that we're all on the same page. So if n is equal to m, then I'm going to show you what the rule is. All you have to do is look at the coefficients of x, in this case 3 and 7, and that is your limit, 3/7. It's that easy. That is only if n is equal to m. And of course, we're going to use formal notation to write this, so your official answer should look like this. And there you have it. So that's our first rule. Let's take a look at our second. All right, now, in this case, this rational function looks almost identical to the one before, except 3x to the fourth power is now 3x cubed. So the case that we're going to look at here is when my numerator exponent, when n happens to be less than the leading term of the denominator. So that's m. Okay. So the rule here is that no matter what happens, this numerator will never ever be as big as this denominator because the exponent is bigger. So the limit here will always approach 0. And of course, in formal notation, your answer will look like this. All right, let's take a look at our third type. Okay, so in this example, let's take a look at our leading terms. First of all, they are where they're supposed to be. And now I have my n term being larger than the m term. So this is a case where n is greater than m. Now, there are two different cases of n being greater than m. And in this case, n happens to be 8 and m happens to be 3. When I take the difference of these two, it happens to give me an odd number. And if you remember from pre-cal, there's a difference between odd and even functions and what happens when they go towards infinity. So this is going to check that. So these two circumstances have to be true. N has to be greater than m, and then the difference between those exponents has to be odd. And what happens, if that's the case, is that this will always be approaching negative infinity. So let's take a look at this instead. Now, this is very similar to the problem that we did before, because my n exponent, my numerator exponent, is larger than the denominator. So n is still greater than m. However, when I take the difference of those exponents, it gives me an even number. So this is an even function. And what happens here, as long as this number is even, this limit will always go towards positive infinity. So those are some shortcuts as to how to take limits when you are approaching infinity, and you need to start utilizing them as soon as possible. It's going to make your life a whole lot easier.